Hi and welcome to another Carpenter Tutoring tutorial. I'm Amy and today we are going to talk about how to solve for variables in equations, the steps that we have to take, and the tools that we can use to help us through these problems. Whenever you're being asked to solve for a variable, there are a couple steps that we can follow to answer any question that we might be given. We'll talk through those steps first and then put them into practice to solve the equation we see on the right side of the screen. The first step that we have to take in solving an equation for a variable is identifying that variable. What are we actually working towards? If we know what the variable is, we know what we're trying to get alone. We want that variable to be alone on one side of the equation so that we can ultimately find what value it represents. In order to do that, we have to get the variable all by itself. So the variable on one side of the equal sign and the number that it represents on the other side of the equal sign. That means our job in solving for variables is to get all of the numbers away from the variable and put them all on the other side of the equal sign. To know how to do that, the first step we have to take is figuring out all the relationships or operations that we see connecting numbers to the variable. And we only have to worry about the numbers that are on the same side of the equal sign as the variable. Once we know that those relationships are, we can break them by using the opposite operation. What I mean by that is, if you see an addition relationship, you can break it with subtraction. If you see a subtraction relationship, you can break it with addition. If you see a multiplication relationship, you can break it with division. And if you see a division relationship, you can break it with multiplication. Now, like we see in the equation in our example, there can be multiple relationships connecting numbers to that variable at the same time. So how do we pick the order of operations that we should break? We've talked about order of operations when simplifying expressions, and in that situation, when we have all numbers and no equal signs, we used PEMDAS for order of operations. Well, it turns out when we're trying to solve for a variable, we have to use the exact opposite order. I call that opposite order SADMEP. It doesn't sound like the nicest name, and it might match how some students feel about algebra, but at least it gives us a tool that we can use to determine our order every single time. So what this means is we're going to break any subtraction or addition relationships with the variable first, then division and multiplication relationships, then relationships with exponents, and after we've gotten through all of those, we can start to tackle relationships that might happen inside parentheses or other grouping symbols, whether they're actually expressed in the problem or implied by the structure of the problem. We'll talk more about that second option with our example. As we're working through and breaking those relationships, of course, our most important idea is to make sure that we maintain balance on both sides of the equal sign. We can think about both sides of the equal sign like ice cream cones that we're giving to two twins. If I put sprinkles on one of the twins' ice cream cones, I'd better be putting sprinkles on the other twin's cone as well, or else they're going to be really upset. And then the two twins will be out of sync, right? They won't have balance with their ice cream cones, and that's going to probably cause a fight. So whatever we do to one side of the equal sign, we have to do to the other one as well. So if we subtract a number from the left side of the equal sign, we have to subtract that number from the right side of the equal sign as well. This is how we maintain balance as we move throughout a problem. Now that we've talked about the different steps that we have to take to solve for variables in equations, let's take a look at the problem we have on the screen. We have the quantity 3x plus 5 divided by 2 equals 4. The very first thing that I need to do is identify the variable. In this equation, I see that my variable is x. Now that I know what my variables are, I can start thinking about the operations that are joining the variable to these other numbers. Well, I see one connection here between the 3 and the x. This is a multiplication connection. I see a connection here between the 5 and the x using addition, and I see a connection between the 2 and the x using division. Now, one thing I also notice at this point is that I have a fraction. Anytime you have a fraction, the numerator is always inside secret parentheses and the denominator is always inside secret parentheses. We tend not to show those parentheses, but they're there because of the position in the fraction. It tends not to matter when we just have a single term in the numerator or the denominator, like our denominator in this case. It's just the number 2. There aren't any other terms connected using addition or subtraction. So our parentheses don't make a difference there, but they will make a difference in the numerator. So here I need to add those secret parentheses so that I know that really the 3x plus 5 is trapped inside parentheses, which means it will be the last section that I worry about when it comes to breaking those relationships, because in SADMEP, we handle parentheses last. Now that I've worked through the operations that are connecting x to other numbers, I can start to think about how I need to break them. And as I think about breaking them, I'll need to make sure that I keep the correct order. So steps 3 and 4 really kind of happen together. As I look at SADMEP, I'm considering first any subtraction and addition relationships that I have that aren't trapped inside parentheses. We do have one addition relationship, but it's inside the parentheses, so I have to wait until later to break that relationship. So I don't have anything with the S or the A in SADMEP yet, so I can move down to the division and multiplication. With division and multiplication, I'm looking for either of those operations outside the parentheses. We do have that with the 2. The operation connecting the 2 with x at the moment is division, right? Because any fraction symbol is really just a division problem waiting to happen. In order to break the relationship between x and 2, I need to use the opposite operation. The opposite of division is multiplication, so I know I'll be multiplying on both sides. The question is, what do I multiply by? Well, we multiply by the number or value we want to get rid of. I want to get rid of the 2 so that I'm closer to having the x on its own, and that means I'll be multiplying by 2 on both sides. Because I've multiplied by 2 on the left side, multiplying by 2 cancels out dividing by 2, because 2 over 2, or 2 divided by 2, is just 1, and any value multiplied by 1 is unchanged. So what we've done is turned that dividing by 2 into multiplying by 1, and that's not going to impact the value of 3x plus 5. Now that we've gotten rid of the 2, the rest of the equation drops down as it had been, but without the 2. So we'll still have 3x plus 5 on the left-hand side, and that's equal to 4 times 2. Well, 4 times 2 is 8. And again, we had to multiply by 2 on the right side as well to keep our balance. Now that we've gotten rid of our denominator, we no longer have a fraction. And since we don't have a fraction anymore, those secret parentheses go away. This means that we are technically inside the parentheses now, and SADMEP restarts. So we begin at the top again and work our way back down to break those remaining relationships. So that means the first relationship I'm going to consider now is any subtraction or addition with the variable. We see that x is being added to 5, so I'll have to break that relationship. The opposite of addition is subtraction, so I know I'll be subtracting a value from each side. And what I have to subtract is the value that I'm trying to get rid of. I'm trying to get rid of the 5, so I will subtract 5. On the left side, 5 minus 5 becomes 0, and 3x plus 0 is just 3x, so we have 3x remaining on its own. On the right side, 8 minus 5 becomes 3, so now we have 3x equals 3. I've completed the subtraction and addition portion of what used to be the parentheses section, so now I move on to division and multiplication. The last relationship I see is that x is being multiplied by 3. We undo multiplication with its opposite operation, division, and we divide by what we want to get rid of. I want to get rid of the 3, so I will divide by 3. Because I've done that on the left side, I also have to do that on the right side, keeping balance between both sides of the equal sign. On the left side, 3 over 3 just becomes 1, and 1 times x is still x, so now we have x on its own. On the right side, 3 divided by 3 is also 1, so I can simplify that to 1. Now I've gotten to a point in my equation that tells me x represents the value 1. To verify that I've done everything correctly, I can plug this value of x, 1, back into the original equation and make sure that it holds true. To do that, I would have 3 times 1 plus 5 divided by 2, and I would want to make sure that that equals out to 4. Well, I have to tackle the numerator first since it's technically inside parentheses. And again, the reason I have to do that now is we're simplifying an expression that uses all numbers. When we're simplifying an expression with all numbers, so all numbers, no equal sign, we use PEMDAS. When we're solving for a variable, we use SADMEP. So it's really important to remember when we use each. In this case, I'll use PEMDAS. So I'm working inside the secret parentheses on the top first. Within those parentheses, I have to consider order of operations, and I will start with multiplication because in PEMDAS, multiplication comes before addition and subtraction. So first I'll do 3 times 1. 3 times 1 is 3, so I can just write this as 3. Now I can do 3 plus 5, which is 8. And since I've gotten this numerator down to a single term, those secret parentheses go away. Now I can look outside where the parentheses had been to consider this additional operation of division. 8 divided by 2, or 8 over 2, is 4. So we see that by plugging in the value of 1 for x and then simplifying our expression, we ended up with 4. Because we ended up with the value that our question put on the other side of the equal sign, we know that we found the right value for x. Now, I will admit that this example was a very difficult one to start with. Don't worry if this feels overly complicated at the moment. The reason that I went for something this tricky at the beginning was I wanted you to be able to see multiple steps handled all at once. All that being said, I also have additional videos that show one-step problems where there's just one relationship to break to get that variable by itself, two-step problems, and then more problems like the one that we saw here today. So if this one feels a little too tricky, I'd encourage you to look at one of the lower number of step problem videos. Nevertheless, I hope it's been helpful to go over some of the steps that we can take to solve any equation for a variable. As always, if you have questions or other topics that you'd like to see covered, please let me know down in the comments. If you enjoy our content, I hope you'll consider liking this video and subscribing to our channel. Thank you so much for spending part of your day with me, and I'll catch you next time.